So using this thermal imaging camera, this infrared camera, it becomes apparent the temperature difference between the kettles. As you can see, the hot kettle on the left emits much more infrared radiation, shown by the brightness of the kettle using this type of camera. And the kettle on the right, which hadn't been turned on, emits far less infrared radiation. Remember, all objects emit infrared radiation, but it's the hotter objects that emit more. Applications of this are many. Some prominent ones are in thermal imaging using satellites for weather systems to help with identifying hurricanes and storm patterns. And there are many military applications, such as night vision goggles and so on. Okay, so you can see here the hot kettle and my hand. You can see my fingers are colder than the rest of my hand. Okay, I'm just going to touch the outside of the kettle, and you can see some transfer of thermal energy there. And now I'm going to put my hand inside the water. Don't worry, it's not boiling, but you can see it's much hotter than my fingers. It's like a nice hot water. It's like a hot bath. And you can see when it goes on the table as well, the hot water drops on the table still emit more infrared radiation than the table. And so I'm just going to add some to the cold water kettle now, and we'll see how the waters of different temperature emit different amounts of infrared radiation. Okay, so if I pour it in, you can see it swirling like milk in tea, but it's really just waters of different temperature. And finally, I just want to show you that the same way light is reflected by mirrors and other shiny surfaces, so too infrared radiation can be reflected. So you can see here me and my reflection in the whiteboard.